The next unit that we're going to take a look at is percent of change, and this will be the last part of our percent proportion idea. We are still going to use the same general format of percent proportion. Percent will go over 100. 100 goes on the bottom left. That way we stay standard. Percent of change. A lot of things that get talked about, especially in advertising and selling, is percent of change. How much percentage is something growing, or how much percentage is something decreasing? So when you go to the store and buy a bottle of something and they sell a bigger bottle and they say 40% more. So it's not necessarily an amount more, but it's a percentage more. So this has grown into 40% more. A lot of advertisers and companies use this to entice people to say, oh, I want that, I want that. But it gets used a lot of times in history, day-to-day stuff. So the basic is this: percent goes over 100. In all of these problems, you're going to get two values, a start and an end. Now, the end number may be higher or it may be lower than the start, but it is important to read left to right in the problem. The start number is the first number you come across. It always goes on the bottom. This is my starting value. Everything is compared to the starting value. Now, what goes above it is the difference. The difference of the end number minus the start number. Okay? Now, it's not always end minus start. It's these two being subtracted. So we always want a positive number, so you have to take whichever is biggest and do it first. So let's say I started at 120. I ended at 80. I would subtract 120 minus 80 and get 40. Let's say I started at 20 and ended up at 80. I would reverse it and subtract 80 minus 20 and get 60. So the difference is the subtraction of the two numbers, so that you always get a positive answer. Difference over starting value. Let's take a look at two examples here. This one actually is from the work you will do for your assignment, page 318, number 15. The question talks about life expectancy. If you have not figured it out, people are staying longer or getting older as time moves on. Why? Because of medical advances, doctors and things like that. So you actually live longer the more that time goes on. It used to be the life expectancy was 47. Now it's stretched out to 77. So what we want is a proportion. Make my blank proportion. Percent over 100. I don't know the percent. I'm trying to figure out what is my percent of change. 47 to 77. Now take a look at this. The starting value is always my first number in the problem. 47 is where I started. 47 goes on the bottom. It's 47 changing to 77. Ask yourself, is this an increase or decrease from 47 to 77? Hopefully you said increase. Yes, we are increasing from 47 to 77. Now the top number is the difference. I must subtract these so I get positive. Big minus small. 77 minus 47, 30. The setup always is the hardest part. The solving should not be hard. So difference of the two over top the original number. So this is going to be a percent increase. Use my algebra to solve. Cross multiply. 30 times 100 is 3,000 equals 47x. Multiply by the reciprocal. The reciprocal of 47 is 1 over 47. 1 over 47. X. We always want to talk about percents in terms of whole numbers. So even if I get a mixed number or a decimal, I'm going to round it. 1, ABC 47 times 3, 1, 2, 3 zeros equals 63 and 39 over 47. Round is a wavy equal signs. X equals 39 is close to 47, 64%. So this is a 64% increase in life expectancy. That's over half. So as you look at this, you're taking half of this number, adding it on. So this has been bumped up by more than half of this original number. So I'd say that's pretty good that life has been increasing by 64%. I'm going to put the word increase here just so we're clear that it did not decrease. Let's take a look at another example. The new year is a special time of the year because everybody thinks about, oh, I could lose some weight. Maybe not you guys, but older people do. Say, this is the time, my New Year's resolution. I'm going to do it. Well, let's see. I don't make those resolutions because I never keep them, so I don't bother starting. Mr. Long weighs approximately 275 pounds at this point. Let's say he does want to get down to 230. What percent of Mr. Long would we be losing? I know that's hard to believe. We don't want to lose any percent of Mr. Long. I'm just kidding. Remember, starting value always goes on the bottom. Where am I starting? My starting point is 275. The difference of the two numbers is up top. 275 dropping down to 230 is a decrease. 275 minus 30 is 45. So you can look at this and say, okay, he wants to lose 45 pounds. But what percentage of him is that? So this is my setup. Difference, 275 minus 230 is 45. Total, 4,500 equals 275x times the reciprocal, 1 over 275. 1 over 275 equals 1 over 275 times 4,500 equals 16 and 4/11, which rounds to 16%. This is a decrease Now, when you look at that, that's not that bad. 16%, that's not a lot. Now, yes, it is 45 pounds I would have to lose, but 16% of me doesn't seem that much. So this is percent of change. Take your first number, does it expand into a bigger number or contract into a smaller number? Okay. Find the difference of the two numbers, that goes up top. Take the starting value, the first number in your problem, and it goes on the bottom. Solve, round to the nearest whole percent, figure out did you increase or decrease, and you're done. Good luck.